the three-story problems first. And so kids kind of get wigged out when they see story problems anyway.
That's neat.
So let's try one. So here we have, this is like a garden area, okay? And we're going to expand that garden area out. Okay? So this is the original garden area, this is the new garden area. We know that this is x, and this is x plus 3. We're going to expand it this way 7 feet. Oh wait, no, not 7. Yes, 7, that's right. Okay, that's the information we know from the picture. And then it's going to say this. You want to enlarge the size of your rectangular garden. The area of the enlarged garden is represented by the following equation. And again, this isn't exactly what's on the test. It's the same type, right? Okay, now, Shelly, if you want to, you can kind of zoom in on those things as we do some of this. All right, so write a binomial that represents the length and width of the enlarged garden. Okay, write a binomial that represents the length and width of the enlarged garden. Thanks, Jaren. So the length we know is what? X plus what? 10. Everybody agree with that? Well, that's telling me what one of the factors is, by the way. What's the other factor? How do I do this? Just read it what? Read it backwards. What multiplies to be 50 and adds to be 15? Yeah, it's 5 and 10, so it's just going to be an x plus what? 5. This one represents the what? Sorry, x plus 10 represents what? Length. And width is x plus 5. Okay, then it says this. In the enlarged garden, how many feet longer is the length than the width? So this is part B. How much longer is the length than the width? This is actually kind of just a simple math problem. It's just wanting you to do what with those two things? Subtract them. Yeah. All we're doing is subtracting. X minus x would be 0, and 10 minus 5 would be 5. So 5 is the what? Is the difference, or difference between length and width. Okay, that's part B. So this was part A, the factoring. Part B is this. What is the difference between length and width? How did we get this? We subtract it. Okay, that's going to be how you do it on the test.
Why did I write mine so big?
Okay, the last part says this. The area of the enlarged garden is 150 square feet. Find the dimensions of the original garden and the enlarged garden. Okay, so I have x squared plus 15x plus 50 should equal the area of the enlarged garden is how many feet? What did I say? The area of the enlarged garden is 150 square feet. So this should equal what?
150.
150. Okay. Could I have written that times that equals 150? Yes, but if I do that, what would I have to do with them? Multiply them out anyway. You see what I mean? Because I got to be able to set this equal to 0. That's the mistake kids are going to make. Some kids are going to write this times this, and then they're going to write equals 150, and they're going to set that one equal to 150 and that one equal to 150, and they're going to miss it. Don't do that. Okay? Set the multiplied out version equal to 150, and then subtract. That's negative 100 equals 0. How do I know I have to set it equal to 0? We have an x squared that we can't simplify. So that's how you know you have to set it equal to 0. Now I just read it what? Backwards. What multiplies to be 100 and subtracts to be 15? 20 and 5. X and x, 20 and 5. That multiplies to be 100, and it will subtract to be 15. Now, it's a difference, so the signs are what? Different. Let me make that 20 look better. There we go, 20. It's a difference, so the signs are different. Which one gets which sign? The bigger one gets the sign in the middle, right? So the 20 gets the what?
Subtract.
Plus, and the 5 gets the minus. The plus was in the middle there, okay? Now, I should set each factor equal to what? 0, x plus 20 is 0, and x minus 5 is 0. So x is negative 20, or x is what? 5. Are both those answers good? No. Which one isn't any good? Negative 20. There's no way that that x length is negative, right? So anytime you get a negative answer in a real world problem, it rarely works. Sometimes when you plug it in and everything was negative to start with, a negative times a negative would make it what? Positive. So don't just automatically say negatives don't work, but generally speaking, plug them in and see if they work. They probably won't. Okay? Does the 5 work though? Yeah. So then it says this. Find the dimensions of the original garden and the enlarged garden. So what's the original garden? It's a 5 by what?
8.
It's a 5 by 8. Okay, that's the original garden. Okay, so this is the width of original. I'm just going to put WO there. And this is the length of what? Original. How did I get that? I just put in a 5. 5 plus 3 is 8. Now you can either put it in here or you can just think about it. But let's put it in here. What would the length of the enlarged be? So length of E for enlarged is what? Just put the 5 in there. 5 plus 10 is? 15. This whole length would be 15, which makes sense. And then the width of the enlarged will be what? It doesn't have anything here, but that's okay. I still have it here. 5 plus 5 is what? 10. So really this would be 5 up in here. The length of the enlarged and the width of the enlarged, the length and width of the original, those are your answers. That's part C. All I did is plug in the 5. Everybody got that? 5 plus 3, 8, 5, boom. Right here's the length and width of the enlarged. So 5 plus 10, 15, 5 plus 5, 10. Everybody got it? Any questions on that one? Okay, so that's the first part. Okay, it's got parts A, B, and C. It's actually the very last one. Like I said, I'm working my way backwards, so that's the first type. Okay, here's the next one. Oh my gosh, are you freaking kidding me? All right, this one's really easy. Okay, two people are gonna kick a ball up in the air. So let's draw them. Here's a person kicking a ball up in the air. Ball's gonna go up and come down, okay? The equation that represents the amount of time it's gonna take for that ball to go up and come down is the following. Negative 16t squared plus 38t plus 1. And this person's also kicking a ball. It's bouncing towards them as they kick it. And they kick the ball and it's up in here, so the ball's up in here and they're going to kick it. Okay, so they're going to kick that ball, and their equation, same thing, going like this. They're going to kick it and it's going to be negative 16t squared plus I don't know, let's go 45t plus 3. Okay? Now, first of all, do you know what every one of those coefficients represent? So this is equal, by the way, this is equal to the height after t seconds. This is equal to the height after t seconds. Do you know what the negative 16 represents? We talked about it a little bit before. Gravity, very good. So negative 16 represents the gravity. What does the 1 and the 3 represent? Yeah, the starting height of the ball. So this one's kind of dribbling towards them and it's maybe a foot off the ground and they're kicking it. But this one is how far off the ground to start with. 3 feet. That's what the 3 and the 1 represent. Okay? What does the 38 and the 45 represent? How hard they kick it. That's the feet per second that they're kicking it, the force applied to the ball. Okay? Or the velocity, if you will. Force or velocity, however you want to think about it. So they're kicking it 38 feet per second, and these guys are kicking it at 45 feet per second. So this guy's kicking it harder, right? Okay, now it says this. Your friend and you each kick a ball up into the air. The polynomial is represented by the heights and feet of the soccer ball after t seconds. Write a polynomial that represents the distance between your ball and your friend's ball after any given t second. That's actually pretty easy. Listen to what I'm saying. Write the polynomial that represents the distance between your ball and your friend's ball after 2 seconds. A distance
So they
between,
just
what am I going to
subtract
do?
them?
Yeah, very good. Remember, you say that again.
Subtract them.
All I'm going to do is subtract them, right? Subtract them. Which one's kicked harder, by the way? Yeah, your friend is kicking it harder. So we're going to take his, subtract yours. Everybody with me? So I'm just taking this one and minusing. Now I'm going to, when I minus this, I got to distribute a what? A negative all the way through. So I'm going to have a plus 16t squared. I'm going to have a what? Minus 38t. And I'm going to have a what? Minus 1. So the difference between these is going to be, what is that? 7t plus 2, right? That represents the what? The difference between the height of the balls at any given second or partial second after it's kicked, after you both kick them, right? That's going to be the difference in the height. So that's how I do that. Interpret the coefficients of the polynomial in part A. So what does the 7 represent? How much what they kicked it. How much harder they kicked it. And the 2 represents how much higher it was when they first kicked it. Those are the 2 things that you need to kind of interpret. You can have a couple different answers there. Just something that kind of explains that. That one was kicked harder, 7 feet per second harder, and it was also kicked from 2 feet off the ground higher. Something to that effect. Okay? So that's all the second one is. Last one is this one. This is pretty easy too. All right. So you have a milk carton. Now we don't have very many milk cartons anymore. Almost everybody buys jugs of milk or whatever. But let's say you have a milk carton. Okay? So you have this milk carton, and it actually is the shape of a rectangular prism. By the way, I bought like chocolate milk at like Sam's Club, and it was seriously this. It was a rectangular prism. It was weird. Like the cap on top of it was sitting right here, but it was seriously like rectangular. Like there was nothing up here. They used to make cartons like this, right? To ship them easier, they actually made it so they were perfectly rectangular. So we have this rectangular prism. I'll just kind of dot this out. Dot this out. And so we have this milk carton. Everybody with me? This is the milk carton. All right? Here's what it says. The width of the milk carton is 20 centimeters. So the width, that's here, that's 20 centimeters. Okay? The depth is d centimeters. And the height is d plus 25 centimeters. Okay? So by the way, there's no picture drawn. I just drew my own, right? The minute I heard rectangular what? Prism, I drew my own. So there's no picture on this one. You're going to want to draw your own. Okay. Now it says this. Write a polynomial that will represent the volume. What's volume of a prism? Just length times width times what? Height. Okay, so d times d plus 25 times what? 20, that's it. Okay? All right, write a polynomial that represents the volume in cubic centimeters of the milk container. Write the polynomial in standard form. Is that a polynomial, by the way? Yeah, and this would equal what? Volume. That's a polynomial. I just haven't multiplied it out. If it wants it in standard form, what should I write? How do I get this in standard form? What am I going to do? Just multiply it. Distribute everything through. I'm going to put the 20 with the d. Is that okay with everybody? Yeah, now I'm just going to distribute the 20d. So what do I get? Maddie. Is that right? Yes. All right. Maddie, what will you get when you distribute? It's 20d squared plus what?
140.
Anybody know what 20 times 25 is? 500 d. Okay? So there's my representative of the volume in standard form. And then it says, what is the degree of the polynomial? What is the degree of that polynomial? 2. It's the highest exponential value, right? And then it says, what is the leading coefficient? 20. It's the number in front of that squared term. And that's all it asks. It doesn't have you set it equal to anything or nothing. So, everybody got it? Those are the 3 other ones. I'm going to do one grouping one, and then you can stop that, okay?
Stop. Okay.